Hello, and welcome to the first video for 9.5, combinations of functions. Once again, we're looking at something we have seen before this year, presented in a slightly new way. So we've got the same function from the last section, f of x equals negative x squared plus 3x plus 4. We're going to look at a variety of combinations with this guy. We actually did a couple things with function notation in the last video. We started plugging in numbers, which was fine. But let's be honest, kind of boring at this point. So let's plug in some different things now. Let's plug in lots of things. This first one, let's plug in 2x. Okay, so I've got my function. Instead of x, let's plug in 2x. So we're going to take all of our x values here. We're going to kick them out. And for every x that's in there, I'm going to put 2x. And then I'm going to simplify, because I can simplify just a little bit. This guy's going to become 6x. This 4... it's going to become a negative 4x squared. So we simplified this. We bumped up those first three by 2. Very cool. Not exactly the same thing in the next one. Since I'm dealing with limited space here, I'm going to change colors as we go. I'm going to do 2 times the whole function, which means 2 times on the outside. You might be thinking, well, okay, doesn't that not change anything? You times by 2 the first one. Watch this, though. We get negative 2x squared. That 2 is not squared this time. Only the x is squared, plus 6x plus 8 on the end. So every single one of the coefficients was bumped up by 2. All right, so it's difference between multiplying your input versus multiplying your output. This last one on this page, we're going to add 2 to the input. Let's add 2 to everything inside. So let's leave our holes here. Plus 3. So I've kicked out every single one of my x's. Now I'm going to put in an x plus 2. Okay, this second part's a little easier to simplify. Some distribution there. Squared, I've got binomial times a binomial. So I'm going to go off to the side here. X plus 2 times itself. I get negative x squared plus 2x. 2x is 4x plus 4. Okay, then I'll distribute that negative. We get negative x squared. Negative, I'm going to need some more room. Sorry. Negative x squared minus 4x minus 4 plus 3x plus 6 plus 4. Combining like terms gives us negative x squared minus x. Those two cancel, plus 6 is our final function. Sweet. Instead of putting it in the input, let's take it and put it in the output. So let's put negative x squared plus 3x plus 4. Now we're going to add 2 to that. Oh, this is so much easier. Negative x squared plus 3x plus 4 all stays, or plus, no, that first part stays all the same. Instead, it's now just plus 6. So all we've done is transformed it a little bit. This last one, it looks like they don't want us to just add a 2. They want us to add the output of 2. So they want us to find f of 2. What on earth is f of 2? Let's see. F of 2 would be to just plug a straight 2 into the function. And so we would get 4 squared negated plus 6 plus 4. I believe we've done this in the last section. It's 6. And so what they want us to do is take f of x and add 6 to it. So negative x squared, pardon me, I did not switch colors, plus 4 plus 6, we get negative x squared plus 3x plus 10. All right, so 5 different ways you can mess around with a 2 being inserted into your function. You could put a 2 in the input, or multiply 2 in the input. You could multiply 2 in the output. You could put an add 2 in the input. You could put add 2 in the output. You could find the output of 2 and add it in. These are all what we call arithmetic operations, okay? Adding these things together with constants, okay? So some people call it scalar arithmetic operations. But what happens if we kind of bank off this last one and start doing it with functions and other functions? Well, what we get is more of the arithmetic function operation. So function arithmetic takes on its own unique little notation, but it's nothing to be scared about. If you see something like this with an operation in the middle, if you see plus in the middle, it means add the functions. If you see minus in the middle, it means to subtract the functions. If you see a multiplication in the middle, it means to multiply the functions. If you see a divide, you divide the functions. Just make sure your g of x doesn't equal 0. All right, so let's look at these 3 functions here. We've got f plus g of negative 1. So they want us to do 2 things here. Actually, they first want us to add the functions. Whoops, sorry about that. And then actually find of negative 1. They want us to plug in negative 1 at the end. So let's go ahead and add f of x I'm going to need to zoom in so I don't run out of room. F of x plus g of x, which would be 6x squared minus 2x, plus our g of x function, 3 minus 1 over x. Now notice I didn't bother putting in parentheses because parentheses are unnecessary. I could put them in, but what's going to happen? I'll just take them back out anyway. This is actually going to end up being our function. I don't know if you noticed, but there is not a single like term here to be combined. So this is our f of plus g of x. We'll go over here now and actually plug in a negative 1. 6 times negative 1 squared minus 2 times negative 1 plus 3 minus 1 over negative 1. We get negative 1 squared is 1, so 6 plus 2 plus 3 plus 1. 6 plus 2 plus 3 is 6 plus 6 is 12. There we are. So that is how we would add these functions and then find it of negative 1. Let's do it again, but this time let's do it with multiplication and then plug in 2. So 6x squared minus 2x. Notice the parentheses this time because I want to tell myself, hey, you're multiplying these functions. All right. First round's easy. That's 18x squared, and that's minus 6x. Here, remember, this is just think about this one as a divided by x. So I have 6x squared divide out a negative x. I get minus 6x. See that? So 6x squared divided by a negative x. Those will cancel to an x. Those will become negative. We get minus 6x. Let's do it again with this guy. The x's are going to cancel. I get a positive 2. And so we end up with 18x squared minus 12x plus 2 as our multiplied function. All right, we're going to take that now and we're going to plug in a 2. 18 times 2 squared minus 12 times 2 plus 2. 2 squared is 4. 18 times 4, I could do this. 72 minus 24 plus 2 is 50. Much bigger number this time. Interesting. All right. Now the next two functions, they have determined the domain of the resulting function. Fascinating. We're going to have to look at that. Notice these two functions aren't asking us to plug in after that. So that's already one difference. These two functions aren't asking us to plug in. Instead, they're asking us to determine the domain of what happens after. So let's go ahead and subtract. Ooh, got to be careful. G minus F, not F minus G. So I'm going to take G and subtract F from it. All right, when I do that, I have to distribute that negative. I get 3 minus 1 over x minus 6x squared plus 2x. Written in more of a classic format, we see, negative 6x squared plus 2x plus 3 minus 1 over x. So again, not a lot is going to combine, but it's the first two that change their sign. All right. The domain of the resulting function. Well, most of this is actually okay. Most of this, I'm going to put a minus sign in there, is totally closed under the operations. I mean, addition, subtraction, multiplications, powers. Oh, it's this guy. He could be the problem. We cannot have x equals 0 here. If x were to equal 0, we'd be totally good to plug in up until that last term. And then, boom, it would explode. So we don't want to say 0. No 0 there. All right, same thing with this division now. So we've got 3 minus 1 over x over 6x minus 2x. Okay. We could kind of clean this up a little bit if we were to make this into one fraction. 3x minus 1 over x, and then we could do 6x cubed minus 2x squared over x, put an x on both, and these will collapse. 3x minus 1 over 6x cubed minus 2x squared. We could pull out a 2x from these. 2x squared, and we get a 3x minus 1. Let me double check that. Pull out a 2x squared, yes. And then we could see these two would match, so they would cancel. We'd be left with 1 over 2x squared. Now that is a huge flashback to rationals. So if you have any questions on that, please seek out your teacher. Get some refresher on how that broke down. All right. What is the domain here? Well, the domain, it looks like I still can't have 0, right? I still can't have 0 on the bottom. Sorry about that. Negative infinity to 0, union 0 to infinity as my domain. All right, that's it for this video. We'll talk a little bit more about some things you can do with these types of operations in the next one when we start talking about the difference quotient. See you there.